The programming language known today as C++ evolved from the procedure-oriented language known simply as C. C was developed in 1972 at Bell Laboratories. In 1985, there were several enhancements made to this language. Among these enhancements were object-oriented features. This enhanced version of the C language was renamed C++. C++ is a superset of C, which means that with few exceptions, everything available in C is also available in C++. This means you can use C++ as a procedural as well as object-oriented language. Before using the object-oriented features of C++, you will need to learn how to use C++ to create procedure-oriented programs, and that is the focus of this training CD. The techniques you learn from procedural programming will help you create object-oriented programs later. During the course of this CD, I will refer to a C++ simply as C. To create and execute a C program, you need to have access to a text editor, often simply called an editor, and a C compiler. You use the editor to enter the C instructions called source code. After entering the source code, you then use the C compiler to convert the source code into machine code. Machine code is what the computer can understand, and is often referred to as object code. Many C systems, such as Microsoft Visual C and Borland C Builder, contain both the editor and the compiler in one integrated environment, referred to as an IDE, Integrated Development Editor. Other C systems, called command line compilers, contain only the compiler and require you to use a general purpose editor, such as a Notepad or WordPad program, to enter the program instructions into the computer. Keep in mind that the different C systems, such as Visual C and Borland C Builder, are not different languages. Rather, they are different implementations of the same language. Although I will be using Microsoft Visual C++ version 6 to create programs, you will be able to use the C instructions that you learn in most C systems. I have now launched Microsoft Visual C++. During this course, I will refer to Microsoft Visual C++ as simply C or C++. C++ is simply an enhancement to the original C language. And within the context of this course, it is not important to distinguish between the two versions of C or C++. You will note in the Microsoft Visual C++ window, there are several windows. This window is known as the Project Workspace window. This dark gray area is known as the Code window and will become available to us very shortly. The bottom window, which is white, is known as the Output window. In the Output window, you will receive error messages or other type of warnings or messages from the C compiler. The best way to learn how to write code in C is to simply begin writing code and to understand each line of code as it is entered. To write a new program in C, you simply click on File and then choose New. You'll notice that there are several tabs. The one we want at this point is the Files tab. And then select C++ source file and then click OK. You'll notice now the code window has turned white, which indicates that it is now available for us to begin entering code. By the way, if you would like to create more space, you could close this Project Workspace window for the time being, and now you have a little more room to work. The Output window could also be closed, but for right now, I'll leave it open. Like most programming languages, the C language follows a specific format, which is referred to as the syntax. The syntax of a language is very important. It is simply the rules that you must follow to use the language. One important note, and I will emphasize this several times, is that the C language is a case-sensitive language, which means you need to pay attention to whether you are using uppercase or lowercase. In many instances, you can use upper or lowercase, but you must be consistent throughout the program for a specific word, variable, or keyword. The first thing you might want to type into a program is a comment. A comment is entered in a C program by using 2 forward slashes. These forward slashes will then tell the compiler that what comes next is simply a comment. For example, if I type in this line of code, this will not cause a problem and is considered non-executable code. The C compiler will ignore this line of code when it translates into a compiled or object program. You can use comments to document your program, such as this program will accept numbers and display their sum. Now a person reading this program has an idea of what this program will do. By the way, you can enter as much white space, that is, lines with nothing on it, as you want. The C compiler will ignore this also. So for example, if I want a blank line between my comment and my next line of code, I can simply press the Enter key as many times as necessary. The next line of code will be confusing at first, but is necessary and will become more easily understood as time goes on. I'll first type the line, which is # include open brace iostream.h, close bracket. You'll notice the word include is in blue, which means it is a keyword or reserved word. This is known as a compiler directive. Most C programs include this directive. A compiler directive is a special instruction for the C compiler that tells the compiler to include the contents of another file. In this case, the iostream.h file. The iostream.h file contains the instructions, that is the source code, needed to handle input and output operations, such as entering data from a keyboard or displaying information to the computer screen. Files that have a .h at the end of their names are called header files. Header refers to the fact that these files are included at the beginning or head of a program. Notice that you place the name of the file, in this case iostream.h, in angle brackets. The angle brackets indicates that the file is located in C's include folder. The include folder, which contains the standard C header files, comes with the C system that you have on your computer. As mentioned earlier, remember that the C compiler is case sensitive. Therefore, make sure you spell include exactly the way you see it, that is, in lowercase. Do not use an uppercase I or all uppercase or any other combination. It must be typed exactly as you see it. The next program instruction will be void main. You will see this statement in virtually all C programs. Main is the name of a function. A function is simply a block of code that performs a specific task. You can recognize a function in C by the parentheses immediately following the name. The execution of a C program always begins with the main function. That is, every C program must have a main function. After the function's name, you enter the code that directs the function on how to perform its particular task. In C, you enclose a function's code within a set of braces. That is, an opening brace followed by a closing brace. And if this were a real program, we would have code in between these two braces. Everything between the opening and closing brace is including the main function. At this point, we have the main structure of a C program. We have some comments that tells the reader what this program is going to do. We have the compiler directive, which will allow us access to input and output operations, and we've created the structure for our main function. If we compile this program, of course, nothing will happen because nothing is inside the function. We will begin to write code for this main function in the next segment. Our next step will be to write code that will allow this main function to actually perform a task. The first thing we need are some variables. And I will begin by writing a comment that will tell me, or tell the reader of this program, what the next line of code is doing. That is, I'm defining my variables. In Chapter 2, we will discuss in more detail what variables are and the rules for naming them. At this point, I'm simply going to include some variables so that we can have a program to perform a task. I will explain variables in more detail in Chapter 2. The line of code float num1 followed by a semicolon will declare a variable called num1. I will also declare a variable called num2. Notice that each of these lines end in a semicolon. The instruction to declare a variable is considered a statement, which is simply a C instruction that can be executed or processed by the computer. All C statements must end with a semicolon. Just be aware that not all lines of code are considered statements. Although not necessary, notice that my variables, num1 and num2, have been entered as lowercase. I could have used upper or lowercase or a mixture, but again, you want to be consistent more than anything else in the C language, since everything is case sensitive. My next step will be to write code that will allow data to be entered for the variables, as my comment says. To do so, I will need to use two objects of the I/O stream, and that is cout and cin. The cout statement will display something to the user. The line of code cout, enter a value for the first variable, will serve as a prompt for the user to enter data. The symbols that are now highlighted are known as insertion operators. Insertion operators are used with the cout statement, which is an important part of the syntax. This is cumbersome at first, but the more you work with the C language, the more easily this will be accepted. In this line of code, the insertion operator sends the message, enter a value for the first variable, to the computer screen. Keep in mind, this statement only displays the message on the screen. The statement does not pause the program to allow the user to actually enter the number. You will need to use the input stream, cin, to do so. So let's enter that next. So I'll go to the next line and type cin, and then use the opposite symbols, which is known as the extraction operator. You may want to think of the extraction operator as meaning to get from. That is, to get from the user something from the keyboard. Here's where I will use my variable num1, followed by a semicolon. Notice that both the cout and cin statements end in semicolons. I will need to do likewise for the second variable, and then include a cin statement similar to the first. Now I've created lines of code which will prompt the user to enter data, and then for that data to be accepted into the variables called num1 and num2. As the comment I've just written says, my next task is to add the two numbers together. To do so, I will need a third variable created to hold the contents of the addition of num1 and num2. So when you find this to be the case, you simply need to go back up to my define variable section and create a variable such as total. And then return to the spot in the program and write the line of code that will simply say total equals num1 plus num2, followed by a semicolon. This line of code now will take the contents of num1 and the contents of num2 and store it into the variable called total. Don't be overly concerned about the meaning of the word float at this point. As I said earlier, I will discuss this in more detail in the next chapter. Next task will be to display the result of our calculation. To do so, we will need to use the cout statement since we want something directed to the screen. Use the insertion operator, and inside of quotation marks, display a message such as the sum of the numbers equals close quotes. And then I need to use the insertion operator once more to separate the items of the cout statement, and then display the word total, or type the word total. But notice I do not use the word put the word total in quotation marks. If I did, then I would get the word total as opposed to the sum of the numbers. Finish this line with a semicolon, and our program is almost done. the last thing we need is to make sure that we have our closing brace. And since I inserted some space, you can now see, let me close this output window so you can see the whole screen, whole program on the screen. As you can see, we have our comments, our compiler directive, our main function, which will allow variables to be declared, allow the user to enter data into those variables, perform a simple operation, and then to display the results of our program. Our next step will be to compile this program to see if it actually works. We will do that in the next segment. Before we can execute this program, we need to compile it. In other words, we need to tell the C compiler to translate our source code into what's referred to as object code, or executable program. The method of telling the C compiler to compile and execute a program will vary with different C systems. If you're using a different version of C, then this might vary, and you might want to consult your help facility or your instructions manual to find out the specifics on compiling in your version. Even in the Microsoft Visual C++ environment, there are several ways to compile the program. One way is to click on the Build option on the menu bar and then click Compile. You will immediately get a message that says this build command requires an active project workspace. Would you like to create a default project workspace? Since C requires this project workspace, we need to answer yes. Then we need to specify where we want this program to be saved, since we have not done so prior to this. I have a subdirectory or a folder on drive C called VTC C++ that I will store my programs. I will call this demo1.cpp and store it into this folder. Once the program is now saved, the compiling begins. As you can see down in my output window, I get the message 0 errors, 0 warnings, which is exactly what I was hoping for. Now that our program is error-free, we now need to test it to see if it actually works. To do so, I can return to the Build option and then click on Execute demo1.exe. And what C has done is created an executable version of my program. I run the program, and it asks me if I want to build the exe version. It says the file does not exist. I need to respond with yes. The program is now running, and as you can see, it has opened the DOS window. And it's prompting me for the first variable. I'll enter the number 4 and press enter, followed by the number 9 and press enter. Now you'll notice that the program ran, but the output did not stay on the screen long enough for me to see the output. To correct this problem, we'll return to the last line of our program, where we said cout the sum of the numbers and then total. We can enter the insertion operators followed by ENDL. This is known as inline. The inline command will advance the cursor to the next line on the computer screen after it displays, in this case, the total of our sum of numbers. It also will serve as a pause to allow us to view the output. So since we've now made this change, let's recompile our program by clicking on Build. Once again, we get no errors, no warnings, and then we can go back to Build and click on Execute. And once again, let's enter some test data. And now, as you can see, the program is indeed working. It tells us the sum of the numbers is equal to 14, and to press any key to continue. And that is the DOS message, which allows us to press any key to return to the C environment. So now we have a working C program. One quick note, you'll notice there is a shortcut button to execute the program. This exclamation point on the toolbar will allow you to execute the program without going through the menu. So that is a shortcut. Also, you can click on Build, and you can either click on Compile, or click on Build, or Rebuild All. All three of these will essentially do the same thing. The compile process will simply compile the program. The build will take that compiled program and build it into an executable file. So if you don't want to be prompted for each step, you can go directly to Build, and it will do that for you. That is, compile and build the executable program. In the next segment, I will introduce a few errors into this program to demonstrate how to handle and how to avoid certain types of errors. To demonstrate the case sensitivity of the C language, let's introduce a couple of errors. I'll first change the case of my num1 to capital N down here in the CN statement, but I will leave it as num1 in my declaration statement when I define the variable num1. I spelled it the same, but I've used a different case. Let's recompile this program and see what happens. As you can see, it has given me a message that says one error. If down in the output window I scroll up to where the message is, it will say num1 undeclared identifier. Of course, since we just introduced this error, we know what the problem is. But in reality, we may not know this. So if you simply double-click on this error message, it will then take you to the occurrence of this error. And it tells you that it does not recognize num1. Of course, the simple solution here is to change this back to lowercase n. And then we'll recompile the program, and it compiles without error. Let's discover the importance of this compiler directive include IOString. I will do so by making it a comment. By doing that, you'll notice that it has turned green, indicating that it is indeed a comment. But more importantly, it is now considered non-executable code, which means that when this program is recompiled, this statement as if it will be ignored, as if it's not there. Let's see what impact that program or this introduction of this error will have on this program. I'll compile it, and I get 10 errors, and all I did was make that a comment. Let's scroll up to the top of this, and you can see that it gives me a message that says cout undeclared identifier. And all these messages have to do with the cout and cn statement. In this program, since I have taken away the compiler directive for the iostring.h, it does not recognize anything associated with the cout or cn statements. So don't be alarmed when you get messages that indicate that there are multiple errors. It might literally be just one mistake. In this case, that's exactly what it is, as I recompile this program after correcting it, and of course it is now error-free once more. Now I'll introduce an error with our summation statement, that is where it says total equals num1 plus num2. I will also make this a comment by placing the 2 forward slashes in front of it. Now, I've got the variable total declared, and I am displaying the result of total here. But if I make this a comment, then C will not know what the total of num1 and num2 are. Let's recompile this program. I'll click on Build, because I know it's going to compile. Notice it does give me one warning. Let's take a look at what that warning says. It says local variable used without having been initialized. What this is telling me is that I did not give total an initial value. Well, let's just see what happens when I run this. This is a warning, which means I can run this program. So if I type in some data, such as 5 and 8, I get a result of a very large number, a negative number in fact. And what this is the default number that's being associated with the variable total in memory. This obviously is not our correct answer. So that warning was trying to tell us that we're referencing a variable called total, but we did not give it a value at any place in the program. We could have given an initial value of 0 up here. It says equals 0, 0.0. And let's see what effect that will have. I'll rebuild the program. Notice I'm now back at 0 errors, 0 warnings. I'll use the shortcut button to execute. Click on 5 and 8 again. And now I get the sum of the numbers equal to 0. Remember, I still have my summation statement commented out. But now I do not have a warning because I have given total an initial value of 0, and it remains that for the duration of the program. It's a good idea to always initialize your variables, and we'll talk much more about this in the next chapter. I'll make one last change, that is putting the total statement back as it was, rebuild this one more time, just to verify that it does indeed work. 5 and 7, of course, is 12. Before concluding this chapter, I would like to introduce another error which is very common in the C language, and that is the absence of the semicolon. We've learned that the semicolon is required at the end of each statement. So if I delete the semicolon at the end of this line, total equals num1 plus num2, let's recompile this program to see what error that will generate. As you can see, it says 1 error, 0 warnings. If we scroll up to the error message, it tells us syntax error, missing semicolon before cout. And if we double click on the message, notice the error message or the error indicator takes us to the cout statement, which is not in error at all. The problem, as we well know, is up above where we've left off the semicolon at the end of the line. But this has caused this line, cout, to be considered as if it were part of the total equals num1 plus num2 line, which is an illegal operation. So when you get an error message, don't always assume that the error is on the line that it's referring to, particularly in this case where it says missing semicolon, because the missing semicolon is at the end of the line above the statement in question. Let's recompile this program to verify that this is indeed the problem. And of course it is. Another error type, which is not really a syntax error, but is more of a logic error, is to, for example, use an asterisk instead of a plus symbol. Now if I compile this program, it does indeed compile error-free, and I in fact can run the program. And if I enter a value such as 3 and 5 and press enter, you notice it tells me that the sum of the numbers is equal to 15 instead of the expected answer of 8. Of course, what it has done is exactly what we told it to do, and that is to multiply 3 times 5. But yet, the purpose of the program is to add the two numbers together. So, in this case, you need to pay very close attention to what the program is supposed to do and to use test data and verify the results of that test data. Logic errors are oftentimes the most difficult type of errors to find because the compiler does not give you any help at all. The computer will take you very literally and do exactly what you tell it to do. Now that we've finished with our program, and let me change this back to a plus symbol, we can now save and exit our program by simply clicking on File and then Save. And our program is now saved, and then File and Exit will then terminate this session of Visual C++.